Spirit of Kansas in 1998 finished a mission that was relatively routine and landed at the US Air Base in the Isle of Guam just to refuel, routine stuff. By that point, the Spirit of Kansas had about 9,000 hours of active service, so it worked pretty well. Everybody was pretty happy with that. Those testers in the audience among you are probably now noticing that the thing behind me is not the Spirit of Kansas. It's the spirit of something else. It's the Spirit of Indiana. The reason why I've not been able to procure a picture of the Spirit of Kansas is this happened to it when it tried to lift off. This is the last known picture of the Spirit of Kansas. Upon takeoff, about 10 seconds later, the plane started spinning like crazy. And the pilots tried to stabilize it and kind of quickly gave up, ejected, and they were able to save their lives, but they were badly burned. And this was a total write-off. There was about $1.4 billion of damage there. The military performed an investigation, of course, because you have to do stuff like that with kind of $1.4 billion of damage. And the conclusion was kind of amazingly military speak that only kind of these people can do. So the conclusion was that basically the system performed as it was designed. Amazing stuff. I try to imagine some people in, designing the software to control this plane that were thinking about, well, imagine one day somebody lands on the island, on the Isle of Guam, and they try to take off. Well, what should the software do? Well, John, maybe it should spin like crazy and try and kill both pilots. So you can't tell me that kind of the system functioned normally in this case. And what happened is that the sensors on the plane misinterpreted some particular climate conditions in Guam as turbulence. And the plane control system tried to compensate for turbulence, where, because there was no turbulence, it started spinning like crazy. The punchline here is that the military investigation concluded that all this was due to human error, because there were technicians on the island who knew about potential problems with the sensors, but they failed to communicate it to people kind of designing this plane. And this is pretty much like blaming testers for breaking the system, where kind of the systems typically come to testers already broken. And testers get blamed for basically being the cheapest person available to blame. So, kind of being a bug magnet, as I said, it's a really difficult thing to kind of reconcile that with being a developer. And about 7 or 8 years ago, I worked with a team where we were really, really proud of our development practices. We had continuous deployment before continuous deployment was a buzzword. We have kind of unit testing, again, and a ton of other things that people often talk about but don't do. And we're really, really proud of what we did. But then every couple of months, we'd get a stupid, angry email from customers. And kind of, this really annoyed me. So we got one email that it was quite lengthy, and it started with, this is fundamental stuff that's been explained a million times over and over again. It basically means that this person who wrote the email thinks he's the smartest person in the world and everybody else is an idiot. And I was really annoyed, how could we miss stupid stuff like this? And kind of, at that point, we kind of went to blame the testers, and they said, why the hell did you not test this properly? And the response came back as, we didn't have time to test it, kind of, we'll do better next time and things like that. And this really bugged me as, why do we allow ourselves to let stupid stuff like that through to production? And then again, I realized, hey, I'm making the same mistake as these people. I'm blaming somebody who's absolutely not to blame for that. And we started looking at our process and why the testers didn't have time to do that. We were running 2-week iterations at this point, and because there were lots of developers and very few testers in the organization. Developers tended to develop until Friday afternoon the second week, which meant that testing started to slip over. And if testing never finds anything, why do it? And people generally ignore that even after testing, there's another part there that we don't often consider. That's fixing stuff the testers found. So this part here is something that we completely ignored, and then after I've realized that and started working with lots of different teams, I started noticing this pattern of people having this hidden cost in their iteration. This is a tax people pay for an iteration, being from